right. Good afternoon, everyone. It's almost time to go home. I hope you have really good time with Possible. We shared a lot of our roadmaps, the investment areas, the transformations that we're doing in our product, the way we're approaching the market for the AI at a scale, and the stuff that we are bringing in our stack, right? I'm super excited today to talk about open table format and how it is really changing the modern data warehousing. What is it all about, and how providing an efficient way of compute to the data which is residing in the lakehouse, we align you or make you capable to do AI at a scale in our platform. Because we acknowledge the fact that a lot of the data would not be in our platform, it will be outside of our platform, and we just want to provide you the efficient compute to do that. All right, let's go over I'll just go over the overview to start with. Then we not only talk with our customers, but we also have a lot of feedback from the analysts, like Gartner, Market Search, and a few others, and we take their data to understand the market trend and figure out our investment and stuff. We'll go over the roadmap that we have already delivered so far and what we plan to do next year, and deep dive a bit on the architecture, not too much going into the weeds, just give an idea and the feel about how Teradata is actually differentiating ourselves from architecture perspective to give you the best price performance when processing the data in open table formats. Of course, that will cover the performance and innovation aspect of it. And over there, we're also going to talk about the one thing that we haven't done a good job, but we do an amazing job right now, is how we are giving back or contributing back to the community. What are we actually doing to the open source community? And looking ahead, as a team, as a group, as different companies, we will figure it out. We'll discuss what we are looking at as our next step and what is in our horizon so that we can ask questions, we can discuss in the last 10, 15 minutes. Sounds good? All right. So what's the buzz about open table formats? So let me ask you a question. How many of you are aware of open table formats? What is open table format? OK. Pretty good. In London, I had only a few hands. And how many of your company or organization either have an operational data lakehouse with open table format data already or thinking about to have one? OK, yeah. So one or two hands that went up. So open table formats are in the very beginning stage of its phases. The companies are doing huge amount of investment in the data management strategies and using and exploring the open table format technology as part of the data architecture to create data lakehouses, right? In fact, when we talk to some of our big customers in healthcare or telecom or financials, they already have an operational data lakehouses, right? And what's so special about the open table format is that the open table format brought all of the goodness, like the Iceberg and Delta Lake, of data warehousing to the data lakes and stuff. So it has made it really easy to access those files, access those data. It was possible before with open file formats, but it was difficult and complicated and too much dependencies in the query engines and stuff. So when we talk to our analysts and stuff, what we heard was that by end of last year, the 10 to 15% of data would be in open table formats, and that is going to be more than 30% by end of next year. And more than 50% of enterprises are actually forecasting that 20% of the data would be in open table formats. The global data lakehouse market by end of 2043 is expected to be around $66.4 billion, which was by end of 2023, which was around $8.9 billion, with a growth of around 22.9 at a compounded rate. So the market seems to be exploding. It is going to be there. And we wanted to get a verification from the different analysts to see if this is an investment that we are going to go and do it and how much we would want to invest in that space. So what does the open table format really offer? It's a true separation of compute and storage. So if you look at the right side of the picture, there is one simple, straightforward, single data storage layer that either the data could be in S3 or AWS Gen 2 or Google storage or in the on-prem. And you can have any compute engines that can access the data in any of the formats, right? So it could be a VantageCloud Lake. It could be Vantage Core, which is going to run in Teradata, which is an on-prem solution coming out next year. It could be AI Unlimited, our engines, compute engines, or it could be any open source engines like Spark, right? So it is not really locked into one particular compute engine or anything like that, depending on the usage. The other stuff is that it reduces the data complexity and replication cost. So meaning if you have a single data storage layer and you have all of these compute resources that are coming and reading and manipulating the data, you do not have to really think about a lot about replicating the data to a different places in different zones to ensure that, oh, that application has to read it because I have to really massage it, process it, so that the X application can read it, Y can do some massaging. You don't have to start replicating all of that. That's a single data storage layer, and it's really being read and written by multiple engines, whoever can read and write that format, right? What does it do? It tremendously reduces the cost, your operational cost, because it makes sure that you do not have any stale data or a data that is not anymore relevant because and maybe that data was replicated many months back or hours back or days back, and that data may not be any more relevant for your business right now for the reports or whatever you're doing. So if you do not have a trusted data, then you do not have a trusted AI and trusted work insights that you want to get from it. So this reduction of this complexity is huge in terms of when you have the single storage layer with the whatever open table formats that you're going to use it for to store the data. It's open and connected architecture. This is humongous and tremendous potential for any of the business or for any of the companies that we deliver. Think about one SQL you've written that has gone using a choice of catalog. It's Hive, Glue, whatever unit it is, went to an S3 storage, made a read of it, and then doing maybe a join with another catalog with the data residing in Delta Lake. So you are basically going across catalogs, across CSPs, across different table formats to get the results that you want. It's huge. It has simplified the whole data access pattern, and it has maximized the blast radius so much to get the insight and get the data that you want. How do we leverage OTF and what we do actually that gives you the edge? We'd already talked about the multi-cloud analytics and multi-data lake out of the box. That's our strategy, right? I mean, we believed in that strategy that we want to be catalog independent. We are not going to have our own catalog. We're going to have the read the data, Iceberg, Delta Lake, or Hudi, whatever table format you want it to be. So as our CEO said, we're going to meet you where you need to be met. We are not going to dictate what you're going to use it. No matter what your choice of catalog, whatever your choice of the table formats, we will perform at a scale that nobody can be close to us. That's the whole objective and strategy. And you know what? That objective and strategy not only resonated with the customers, but that also influenced a lot our competitors. You know, the Databricks acquisition of Tabular showed that the world is not going to revolve around Delta Lake format only. Snowflake's making it Polaris as open source basically says that, okay, you cannot have a proprietary catalog to really give you the performance that the customers need. Customers can have their own catalog of their choice of whatever they need to have. So once Teradata basically came across in last year and talked about this open and connected strategy and like no vendor locking kind of stuff, that influenced our competitors. And this triggered a lot of POCs with some of our customers, and I'm going to go a little bit about where we stand with our current technology that we have in market, and what is some of the stuff that is going to come next year. But that is later on. Now, over here in the slide, you see the 45 years of IP leverage for open table format. Yeah, we have the optimized cost-based optimizer. So if you go to the catalog to read the metadata and the files and stuff, it helps you with the data file pruning, meaning what data files that you need for that query to access to give you the results that you want. Well, then everybody has access to the catalog. Everybody has access to that metadata. Then how are you going to be differentiated based on that? Like, what are you doing to really give you the edge that your competitors cannot give you? So we're doing a lot of optimizations. We're already in our optimizer. And for example, the catalog and did the data file pruning. It really helps us to understand what data file that we need to look at. But something that we have really brought in called object-based filtering options in Optimizer, that actually gives us another level of edge on what records to read and what records to skip, so that we don't end up, even with all the files that we've pruned, we don't end up reading the whole file. That is an additional optimization that really helps us to get the performance that we want to really get it and beat the heck out of our competitor, right? Excuse my French. And secondly, some of the things we have done a lot of optimizations in our in-memory hash joins. We have done something called hybrid pipelining, which is really takes out a lot of the intermediate steps when you're doing a joins between multiple tables and stuff. It has reduced drastically those intermediate steps. So it reduces drastic amount of I/O because you don't have to spool the data too much right now. And that also gives us some performance edges, right? And the metadata that the catalog points to and provides it also provides some statistics. Our optimizer, than anybody else, uses the statistics really well to generate the right query plan to give you the optimum query performance. So I'm not going to touch on every feature what we are doing and what we have been going through right now. These are all in the works. But I'm just giving you a hint of the stuff that we're looking, which will give us the differentiated performance than what our competitors provide, right? And of course, we have the massively parallel distributed processing with the AMPs, the workers that basically goes in parallel and does all the work for you. And the intelligent workload management that's also differentiated for us. So far, you guys with me? Making a little bit of sense? Okay. All right. What does it unlock? We talked about the data complexity reduction, reduced cost of data management. Even with a bit of uptake in the compute cycles, you still save quite a bit by having a simplified data storage layer and not replicating data all over the place kind of stuff. It really, the operational cost comes down quite a bit, even if with the uptake of the compute cycles. The flexible compute, we talked about it. Any compute engines that can really write the formats, you can use it. You're not going to lock by one vendor. That's your choice, who does the job best for whatever reasons. And open access and ease of use, and we are always open and connected, and how we provide the ease of use. So ease of use is a multiple way. Like, we provide a simple SQL syntax to really go and access these data files and stuff, and that is when you have a lot of SQL developers and stuff. And we also have something like we will support the iceberg views and stuff, because sometimes you give permissions and access permissions through views. And our Teradata ML package, which basically is used by the Python developers and stuff to really do some analytics, that also needs iceberg views so that your Python users can come in and really exploit these open table formats and data, right? So these are some of the stuff that's going to get unlocked as we deliver these capabilities and stuff. So some of the customer use cases. So we are talking to large telecommunication customer in US, active POC going on, a lot of feedbacks, right? A lot of work together. Good news, not so good news, great news, opportunities to improve kind of stuff. based on where we are with our current offering. I will still go into the current offering a little later. But tremendous learning. And tremendous learning for our customers that, oh, okay, this is what I can do. These are the use cases that are getting open right now. This is possibilities that I have it. Now, since these data files are all exposed to the table, my applications have additional use cases or different ways to access it. It opens up a lot of potentials, possibilities for the customers. So this telecommunication customer wants to develop a vendor-neutral data plane with at least 2x the ROI. They want to have one common data layer in Iceberg, and independent of any specific compute engines. I'm sure you all have multiple vendors doing multiple different things for your business, right? I mean, you want to really simplify your ecosystem, but we all know that there's a gap between what one vendor provides and what you have to capture through another stuff, right? So at this point, they want the compute engines that can really read and write these formats. Then one major retail and commercial bank, they want one bank platform for the data. And data sharing across, again, the same multiple compute engines and leverage OTF and ClearScape analytics to run the bank operations and stuff, workloads. The one online retailer, these two last, the retail and commercial bank and the online retailer I'm talking about is from Europe. And they are doing fraud detection, cost control, flexible compute, don't want to get locked into by one compute, right? Single source of truth in the lakehouse, the data that is landing in the open table format is secured. It is, if CSPs have their own security and stuff to secure the data. It is a single source of truth. You're not replicating left and right the data into different places and try to get some insights. And simplified ETL pipelines to reduce the infrastructure administration, right? Lately, we have released Vantage on VMware. And one of the online retailer of UK, we demoed them the open table format, which is using the Java-based API today, not the native one, not the logic built directly natively in C++ and being executed by AMP. It's the Java UDF that is running on the AMPs right now. So that's the solution today. We demoed them that. It was using a Dell server, I think accessing Iceberg through Hive. And it was a major, humongous hardware refresh deal for us that really the demo actually really showed us the opportunities that they can take over. And that was a very latest news in a couple of weeks back for us. So some of the customers, we're getting a lot of traction in those areas already, even without the most performant solution that we have that's going to come out next year, which is the solution that we have today. So this is an eye chart with a lot of different things written up over there. We started off, I'm going to give you the headlines over here on what to understand and take away from this slide. We started off the work end of last year. We formed a team and we brought together the team, and it was an exciting project to kick off. So what have we done? As I was saying, we provide today Iceberg read and write capabilities and Delta Lake read and write capabilities using Java UDF or Java APIs. So these open table formats have the available Java APIs that we exploit through Java UDF, and we basically do the read and write on these two different formats. With the Java, basically, we have challenges with scalability, concurrency, and memory management and a few other stuff. So you can only go so far with Java, right? I mean, it is right now, we ran some internal benchmark. And of course, let me tell you, we support the Unity, Glue, and Hive catalogs. And we keep adding catalogs as they're coming out. Like, it's not oh, we're going to take 6 months to add another catalog. It's like this. So anything new catalog that are there, or we are not supporting it today, we put it in our roadmap and we get it done if there's a customer there's a need for it. So it's not a big deal for supporting the catalog piece of it. For the Java side, what I wanted to say is that our objective and goal is that we would beat by next year Snowflake and Databricks on most of the workloads, right? But significantly, without having a proprietary catalog, right? We still stay open and connected. We still use the catalog that you bring in, and whatever compute engines write to it, But with all of that, we still want to beat our competitors there. Today with Java, we compared with open source Spark engine. We do not have the best price performance right now, but we beat any of the Java engines available today in the market by 2x. So if you compare today with Snowflake, no. I mean, functionally, it's ready. You want to try use cases. You want to give it a try. You want to see how the writes are going on. If you have to write data from block file system into the Iceberg or Delta Lake, you can give it a try. You can do some kind of your use case validations and stuff and functionally and see how this is all going. But if I have to compare myself today, which is not the objective and the goal of Teradata, is that I'm going to be better than any Java engine, but since this is a Java solution, we are 2x better than in most workloads compared to any Java engines available. So that's the story as of today, right? And then 2025, we support right now AWS and Azure. We will support in Q1 Google. That's also Java, right? Then what is the next rest of 2025? It's a lot of work. Our chief architect is the one that basically gives us the in-DB analytic functions that outnumbered any of our customers in terms of concurrency, in terms of scalability, in terms of performance by X's and multiples of X's, right? So he's the chief architect who is basically working on this. And we have done literally for OTF, because this is the data that we don't write. We are not creating indexes left and right on that data. We do not have all the statistics that we need to generate the best plan ever, right? Even then, we have to be truly performant, right? So it is a lot of heart surgery going on in the database right now. A lot of work we have made progress, but there's still some work to do for us to be there next year. So next year, we will have a performant native version, which is a pure C++ code with no Java. And that is going to give us, the expectation is that by next year, we will be able to meet or beat the performance in most workloads with our competitors. And we're looking also at the security roadmap, because say, how do we do a single sign-on based on if the cloud provider has their own IDP, and how do you do the authentication authorization using the cloud provider's IDP and use that? And maybe the data governance and the access controls are being done by some centralized services. Like, for example, we are working with AWS actively on the lake formation, right? So how can we use something like that for some of the access controls and data access piece of it, right? So there's a lot of roadmap work on security, ease of use aspect of it, because today, you know that we have an authorization object that we store in database, right? And that you have to go and validate against it. And catalogs also need an authorization to it. So there's another authorization piece of it. So there's multiple areas of authorization authentication happens to create and get an access to the data that you need in open table format. Now, this is not easy. This is not what our customers are saying. Give me a simplified way. Once I have authenticated a user, it just goes and gets the data for me without doing multiple authentication in different areas and stuff. So those are some of the stuff from security perspective, ease of use perspective we are working on. Of course, you saw the Billy's show. You can't match it. He keeps us compliant. He keeps us secured. He keeps us covered on the security front mostly. Right? So he does all of the framework for what we need to really look and work on, and then my engineering team kind of drives it within that framework. So that's the overall story on the 2025. The native, the security roadmap and the Java support on Google on 2025, and now you have the Java support for Iceberg and Delta Lake using the Hive, Unity, and Glue catalogs. And that's on AWS and Azure. Hope I made it simple enough for you not to forget that anyway. All right. So OTF on AI Unlimited roadmap. You have probably heard about AI Unlimited, quite a bit of it. So we're talking about AI capabilities. We've heard a lot with multiple different presentations and stuff and everything, like, we're talking about OTF, like how can I give access at a scale, at a certain price performance, that you can get access to the data that's not residing in Vantage and get your insights based on that data. Now, the other thing is, like, one of the other friction is we do amazing and outstanding job at a scale. Really awesome job. Like, I mean, it's very difficult for us, for our competitors, to really match our price performance at a scale that we, on a petabyte base or terabyte base. And then our reliability, our stability, our workload management gives you the results and gives you the information, runs your business predictably every time, all the time. So that's, even the feedback even I got from the customers is like, your migration, amazing. Your reliability, tremendous. Your stability, awesome. Your price performance, great. At a scale, no words. But then next thing is that how do we reduce the friction of bringing users to our platform? What is some of the easiest way that we can engage some of the personas that we do not able to engage easily to our platform, because our platform is always busy, always in production. It's an enterprise platform. I mean, the IT and the DBAs will not allow you to come in there. So what is an easy way to spin up a compute engine or a compute resource within your subscription in your cloud and have all the capabilities that we provide with the database 20.x version? And you can do the experimentation, you can give it a try, you can do your stuff and thing. And if that is something that, and then when you're done, destroy it. It's all on demand, right? It's within your subscription. So that's what I'm not going to go deep dive on AI Unlimited roadmap and stuff. That I think there is other sessions that we talk about it, but you're going to hear a little bit more next year or this year on AI Unlimited. This is one of the way to really give the compute to you easily so that you can do some exploration, or certain personas can do the exploration that they cannot do it easily today. And they have to sometime move the data to Databricks data platform, analytic platform, to do those kind of work and stuff and everything, some kind of model training, blah, blah, blah. And then maybe inferencing can be on our platform or not, but maybe not. So we are actually forcing some of these personas and users to go out of the platform and do this work on another platform. So we are also thinking from the compute perspective, not only from performance, but easy availability of compute to do the experimentation discovery that you cannot do easily. Okay, so a little bit of, without going into too much details on the architecture side, because this could be itself a 45-minute talk easily. The architecture is evolving as we are moving forward and stuff, right? On the right side of the picture, you have the cloud object stores, right? And that has both the data files and metadata files, and the table data can be in the iceberg format or Delta Lake or whatever, Hoodie. And then you have the catalogs, the Hive, Unity, Glue, and other catalogs that is a single source of truth and provide a pointer to the latest snapshot of the data, right? So that's what we use the catalog on. So what is generally a journey looks like today? I mean, and on the left side, of course, our VantageCloud. I mean, I would not say Lake in general. It's true for VantageCloud, or Vantage in general, that you have the parsing engines, you have those AMPs, the parallel processors, and then our award-winning optimizer, right? So when a SQL request comes in, it goes to the parsing engine. Parsing engine connects to the catalog, gets the metadata about the files that it needs to read and information about the files that it needs to read and the table it needs to read, rather, and go to the iceberg, the object stores, do the reading and whatever, spool the data, process it, and return the result back to the user. So that's generally at a 50,000 feet, 500,000 feet kind of a level of processing that goes on, right? And it's an oversimplified version of it. Now, today, in the AMPs, the Java UDFs are operating. And that, in future, it will be C++ code that is natively going to execute at the AMP level. There will be no Java piece of it. And that's what is causing us to be not that performant today because of resources and other challenges. I'm trying to see what else that I missed in this architecture. Okay. So that's at a file level. And then when we read that tables, right, so there could be like thousands and thousands of files. And how do we go parallel? That's where the AMPs come into picture, right? That is the parallel processing unit that each AMP processes each file at that point, right? And so it's like so many way massively parallel that it doesn't matter like how many files we're reading underlying the table. We just are so parallel that we will be able to execute the results, and every AMP will start returning the result as they're finishing, and once all the result is being obtained, we return the result back to the user. I've spoken a lot of things about the key features with our Teradata Vantage. We talked about no vendor lock-in, simple intuitive SQL. And one thing I want to mention that if you try today POC, or even if you're trying with Java UDF today, Java solution today, tomorrow, when the native is already getting checked in and merged in our code, it will seamlessly get converted into the native implementation. You do not have to change a single line of code at your level. No change of code is needed. It will just flip behind the scene to the native. So if you said, oh, I have to do a whole rework of the whole application and blah, blah, if I go into Java, no. Not at all. It's a seamless transition from Java that you have no user impact on your part. It will just fall to the native side, right? So that's one other thing. And security and data governance, I briefly touched about it. I touched about Optimizer. We have integration with Databricks Uniform and Microsoft Fabric. You heard the Satyas. I'm not going to go into too much details on that. And commitment to OTF and innovation. So we talked about the OTF being, native OTF being performance solution. We talked about different way of improving the performance and stuff. But we are really focusing, because we have done a bunch of bug fixing and feature enablement. We have additional features that we have contributed to the Iceberg community already. And we want to do that for the Delta Lake also. So this is something that is a little different in the last few years of Teradata. We want to show you our commitment to this this community. We want to really contribute to the open source area. And this is something that we want to be part of the community and make ourselves a real, true entity in that as part of the community, right? And so there is a lot of outreach on different things that we are thinking about as part of becoming part of the community. And we are exploring a bunch of options, in that zone. But we are actively contributing back with bug fixes and feature changes to that community. So that's something that we wanted to do more, and we wanted to show our commitment to this. Well, key takeaways I wanted to keep you to remember from all of the talk that I've done is it is the best price performance solution to be available next year. It's open and connected. You don't have any vendor lock-in with this, the solution that we have. You don't have to go through specific catalog all the time. You can select your compute engines, whoever can read and write that, and whichever the formats are the data is in, we will read and write it. And whichever CSPs or hyperscalers are having the data, or even on-prem, we will be able to access that. And of course, it's secure. That's all. Thank you. I'll keep for the last few minutes for you guys to have a conversation or talk or anything that you would want to know that I can share today or may not be able to share today, but happy to have some conversation.
So can you talk a little bit about fine-grained access control? If you had a requirement like column-level security, row-level security, how does it work? How does it perform?
So the whole RBAC, the role-based access control and stuff and everything, we have not vetted out the whole security landscape yet because the requirements are coming different for banks and the healthcares and the telecoms and the retailers, and they have like different security requirement and stuff and everything. So we have just done on the data governance piece and the access control piece, we just started to a little bit exploit the CSP's existing solution. Like I said, the AWS Lake Formation that we are right now working together to see how that goes. Because we have a huge bank of North American bank. They actually want us to give them their role-based access control through the cloud formation, their AWS deployment. And they want us to really explore the lake formation from AWS to work on your access control and stuff and everything. So we are evaluating that piece of it and see what else we need to do in our security roadmap for next year.
So thanks for the explanation on OTF and your roadmap. I have a question. Like you have separated compute and data, right? And you have query grid capabilities which can go to many data sources and get it. Though it's not like a prime time data visualization tool. Is your vision to kind of take advantage of that capability that goes across different spaces, and be a competitor to Starburst or something? Is that in play?
Sorry, one more time, please. I
So
didn't catch it.
I want to just understand if your vision is to expand this to a data virtualization type of capability, because that involves a lot more. Like, Query Grid is good, but I think it doesn't play that well when compared to Starburst, right? So push down, intelligent push down, and all those things, and depending on what data sources it's connecting to.
Yeah, so we started looking at data virtualization and data sharing piece of it as part of a roadmap. I think that is something in the back burner right now that we are not looking aggressively in that space. We are totally invested in the open table format right now for next year, and all of the work that we are doing in the database for analytics like vector embeddings and other stuff, but we are not looking at data virtualization space right now. But we can have more conversation on that if there's an influencing discussion that we need to have it and stuff. Definitely with your account teams, you can engage us and the product management to have some conversation around that space.
I just wanted to validate, when you talk about being able to write data to open table format, which is Iceberg as an example, the mechanism that you have in place today, is that based on the NOS feature, or is there something Unity-based feature that you have in place for write and reading the data?
No. So NOS is good and successful today. It started up bumpy. Is it the most optimized solution? No. It is based on table operator and stuff. The writes today through Java is based on the specification from your Iceberg and Delta Lake API access kind of thing. So we are just exploiting the APIs that they expose in Java to read or write it. So we are not using what NOS and stuff and everything. But native will definitely be much more optimized writes. Like, we will write in larger chunks or smaller chunks based on how many chunks we're writing, how many files we need to write. That will be much more fine-tuned and granular and stuff and kind of thing. But today, whatever Java exposes today, that we use it to write the data.
I thought you were using NOS utility, but behind the scenes, the architecture follows the Java API mechanism. But as a user, I would be invoking more like NOS-based utility to write and read
yeah,
data.
so NOS has a different interface, like NOS write, we do
Yes.
it, right, and NOS read kind of thing. And this interface will be really different, and it will be different, little bit implementation, but the writes will be almost in the same ballpark from the user experience perspective between NOS and this.
Yeah. Thank you.
Yeah, but just from a syntax perspective, we're talking about an insert select type statement
Correct.
instead of NOS write. Anybody else? All right, before you go, again, pull out the Possible app, choose the session, scroll past Sub's picture, fill out the survey, and let's give Sub one more big round of applause.
Thank you. Thank you so much.